Welcome back to our Spring Boot tutorial series. Today, we've got an exciting topic to dive into: query parameters. Query parameters are a key part of building dynamic and flexible web applications. They allow us to pass additional information in the URL, making our APIs more powerful and versatile. Query parameters are a way to pass data to your server through the URL. They are typically used in GET requests to filter or refine the data returned by the server. Query parameters are appended to the URL and are usually in the form of key-value pairs. They add flexibility to your API, allowing clients to specify exactly what data they need. Query parameters start with a question mark in the URL. Check out the example on the screen. http://example.com is our base URL, and path is the resource URL. After the question mark, we have our query parameters. In this example, key 1, key 2, and key 3 are the query parameters, with values value 1, value 2, and value 3 respectively. Query parameters are incredibly useful in many scenarios. Filtering results. When you need to filter data, like searching for employees by employee name or department. Sorting data. When you want to sort data in a specific order, like ascending or descending. Pagination. When you need to paginate results, specifying the page number and how many items per page. Optional parameters. When you have optional parameters that aren't needed for every request. These use cases make query parameters a powerful tool for building flexible and dynamic APIs. Ready to see how we can use query parameters in our Spring Boot application? Let's dive in and explore how to make our APIs even more powerful and flexible. In our last video, we created a getEmployee method that used a path variable to fetch employee details by employee ID. But what if we need to search for specific employees in our database? For example, we might want to find all employees named Mohan, all employees working in the developer department, or employees named Mohan who also work in the HR department. And if we don't provide any search parameters, we want to return all employees. This is where query parameters become incredibly useful. They allow us to filter our data based on specific criteria. Ready to see how we can use query parameters to make our searches more flexible and powerful? Now, let's spice up our getEmployee API by adding some powerful search capabilities. We'll add support for two optional query parameters: employee name and department. If these parameters are provided, we'll filter the results accordingly. If not, we'll return the full list of employees. How will our API take query parameters? For this, Spring provides the @request_param annotation. This handy annotation captures values from the URL query parameters and passes them into our method, making it super easy to filter data based on user input. As you can see on the screen, the @request_param annotation has several attributes. Value. This specifies the name of the query parameter in the URL. Name. This is an alias for value. You can use either name or value to specify the query parameter name. Required. This attribute indicates whether the query parameter is mandatory. By default, it is set to true. If set to false, the parameter is optional. Default value. This specifies a default value to use if the query parameter is not provided in the request. Now, let's add employee name as a query parameter to our API and mark the required attribute as false. This way, it's optional to provide this parameter in the request. If it's provided, we'll use it to filter the results. If not, we'll return all employees. Next, let's add department as a query parameter for searching. Now, to enable searching by employee name and department, we need to make some changes in our service layer. First, let's open the employee service class. In the getEmployees method, let's add two parameters, employee name and department. Now, let's open the employee service info class. In the getEmployee method, let's also add the same two parameters, employee name and department. Previously, we were returning all values from the map. Now, let's make our filtering smarter. Open a stream on the map. First, we'll filter by employee name. If employee name is blank, we'll include all employees. Otherwise, we'll check if the employee name from the request matches the one in the map and include only those that match. Next, we'll add a filter for department. Again, if department is blank, we'll include all employees. Otherwise, we'll check if the department from the request matches the one in the map. Now, let's collect the filtered results into a list. This will give us a final list of employees that match the given criteria. Seems IntelliJ has some suggestions for us on the collect statement. Let's check out what IntelliJ is recommending. IntelliJ is suggesting something for our map usage. Let's take a look at the recommendations and see how we can improve our code by following them. Next, let's return the list of filtered employees. Next, let's return the list of filtered employees. Now, let's open the employee controller class. Let's pass the employee name and department query parameters to the getEmployees method in employee service for filtering. Let's start the application. Our application is now up and running. Open Postman so we can test our new query parameters and see how the filtering works. We already created a request for this API in one of our previous videos. Just open that tab in Postman. Hit the Send button without adding any query parameters. This will test our API to see if it returns the full list of employees as expected. As you can see on the screen, the response shows the list of all 3 employees. This confirms that our API works correctly when no query parameters are provided. If you look just below the URL box, you'll see a Params tab. This is where the magic happens. We can add our query parameters here to test our filtering functionality. Make sure to use the exact names we specified in our @request_param annotations in the code. In the Params tab, add employee name and department as keys. Let's start by filtering only by employee name. Untick the department parameter for now. In the employee name field, set the value to Ram. Notice how, as soon as we added the query parameter, it appeared in the URL right after the question mark. You can see employee name and its value right there. This is how query parameters are added to the URL to filter the results dynamically. Let's hit the Send button and see the filtered results in action. In the response, we got the details of one employee, and just as we expected, the employee name is Ram. Our filter is working perfectly. It's awesome to see how our query parameters are dynamically fetching the right data. Right now, our employee map has only 3 employees. Let's add a few more employees to make our testing more interesting. Let's add another employee with employee ID 4, employee name Mohan, and department HR. Let's add one more employee with employee ID 5, employee name Sohan, and department developer. Now, let's restart the application to load the new employee data. The application has started. Now, let's switch to Postman to test our API with the updated employee data. Let's set the employee name value to Mohan in the query parameters. Remember, We now have 2 employees named Mohan in our employee map.
Click Send button.
Let's check the response. We should see 2 employees, both named Mohan. Untick the employee name parameter in the query section and add department with the value developer. As we know, Ram and Sohan are working in the developer department according to our employee map.
Click on Send button.
Let's check the response. We should see both Ram and Sohan in response, confirming that our API correctly filters by the department. Now, let's apply filters for both employee name as Mohan and department as developer. This time, the list is empty. That's because we don't have any employees named Mohan working in the developer department in our map. Our API is correctly filtering out non-matching records. Now, let's change the department value from developer to HR and see what we get. As you can see in the response, we only received the data for employees named Mohan who work in the HR department. This confirms that our API is correctly filtering based on both employee name and department query parameters. Great job, our filtering is working perfectly. Let's make our API even more powerful by adding pagination with a page size of 2. The response should also include page information, like the total number of pages and which page the current response is for. Give it a try on your own. We'll dive into the details and discuss how to implement this in the next video. To summarize, we learned how to use query parameters to filter employee data by employee name and department. We tested our API in Postman to see how it handles different filtering scenarios. We saw how our API dynamically responds to various query parameter combinations. Thank you for following along. If you enjoyed this tutorial, don't forget to subscribe and hit the notification bell so you don't miss any updates. See you in the next video.